Now let us take a demonstrating example on series LCR circuit. Now here you will be having resistor, inductor as well as capacitor. Connected in series to the same EMF source. यहां पे अब तीनों ही एलिमेंट कनेक्टेड हैं. And in case you will be planning to find out the value of current which is flowing into the circuit, then you see you'll have to form the impedance triangle here, and in the impedance triangle will suggest you that the resistance must be plotted to this side, the reactance of inductor must be plotted to this side, XL will be plotted this way, and the reactance of capacitor will be plotted this side, XC, that will be 1 by omega C. You understand? Now, if you talk about reactance, it may be possible that the inductor is dominant, or it may be possible that capacitor is dominant. In case inductor is dominant, then this side vector value will be more compared to this side, and you will be calling it inductive dominant circuit. In case capacitor is dominant, अगर कैपेसिटर की रिएक्टेंस की वैल्यू ज्यादा है इंडक्टर से, so this will be called capacitive dominant circuit. For this situation, let us imagine that the reactance of inductor is dominant. That means अगर हम इसका एक इक्विवेलेंट अगर बनाएं, then essentially you are having just a value of resistance R and this omega L 1 by omega C together. Since both of them are in opposite direction, the net reactance of the circuit I may be allowed to plot like X is equal to omega L minus 1 by omega C. अगर capacitor dominant होता, then X must have been plotted on the other side, and the value must have been 1 by omega C minus 1 by omega L. Does not make any difference. You can say that the net Z value, this is essentially the Pythagoras of R and X. It will become very much relevant that you plot the variation of this complete impedance of series LCR circuit and its variation shown with respect to this omega which you are using here. For the time being, you can say the angle is phi, and this phi will be utilized for calculating the current. अगर ये phi की value यहाँ positive है, then in case you are showing in phasor diagram, then EMF as a reference will be drawn as this way, and the current here will be drawn this side, making some angle minus phi, or you can say the current will be overall lagging the EMF, and the expression of current you will be getting as EMF upon R square plus omega L minus 1 by omega C whole square under root. Understand? जब तीनों ही एलिमेंट सर्किट में कनेक्टेड होंगे, then the formula you will be using will be this. Once again, if you have to calculate the RMS value of the current, then take the RMS value of EMF. If you have to calculate the peak value, then take the peak value of both the things. And as I was saying that it is very much relevant to plot the variation of Z, but we will be doing that essentially in the discussion of resonance. For the time being, whenever you have to find out the value of current which is flowing into the circuit, then you may use this equation, but it is essential that first you will be forming the impedance triangle and then use this expression to get the value of current flowing into the circuit. You understand? Now, with this much formula in mind, let us have the numerical value put into this and try to solve this question in the same series circuit. Imagine that I am giving you the value of resistance as 40 ohm. Imagine that we are giving the value of resistance as 50 ohm. In this inductor part, let us suppose the reactance directly has been given. You understand? Reactance is given as, say, 80 ohm. Or for the sake of convenience, what you can do, you take a convenient value of, say, 40 ohm for resistor and reactance value as 80 ohm and capacitor's reactance as 50 ohm. Of course, in advance it has been calculated that what is the value of omega L, what is the value of 1 by omega C, and say the voltage source which is connected here is 250 volt, 50 hertz. You understand? यहाँ पे ऑलरेडी रिएक्टेंस ऑफ इंडक्टर एंड कैपेसिटर की वैल्यू ओमेगा एल एंड 1 बाय ओमेगा सी फॉर्मूला यूज करके आपको दे दी गई है. जस्ट टू कीप द थिंग्स वेरी सिंपल, द वैल्यू ऑफ रेजिस्टेंस इज 40 ओम और इन दोनों की रिएक्टेंस आपको 80 ओम एंड 50 ओम दे दी गई है. एंड यू हैव टू फाइंड आउट व्हाट इज द करंट फ्लोइंग इनटू द सर्किट. ऑफ कोर्स बाय करंट वी मीन दैट दिस इज द आरएमएस वैल्यू ऑफ करंट you will be obtaining, because this 250 volt, when it has been mentioned, then it's a RMS value which has been mentioned, and this frequency now will not be used because that has already been calculated in the form of reactance. Now, for solving any question like this, you have to first form the impedance triangle, isn't it? अगर आप इसका एक impedance triangle form करते हैं तो उसमें resistance की value इधर दिखाई जाएगी, because that is the convention. The value of resistance 40 ohm will be shown this side. The value of reactance will be shown here. इंडक्टर की रिएक्टेंस XL आप 80 ओम इधर शो करेंगे एंड कैपेसिटर की रिएक्टेंस 50 ओम दैट यू विल बी शोइंग हियर. You understand? So, if you now try to make the equivalent triangle of this, then you know that resistance 40 ohm is coming like this, and the value of reactance net, because one reactance value is 80 ohm, another reactance value is 50 ohm. The net reactance that will be coming here is 80 minus 50, that is equal to 30 ohm, and the total value of impedance that you will be having, Z, that will be the Pythagoras of this 30 and 40, that will be making it 50 ohm. Understand? And for the sake of simplicity, you can also say that this angle approximately comes out to be 37 degree. This is the standard value of a right angle triangle whenever you have a ratio of 3, 4, 5. This is an approximate angle of 37 degree. Here in this circuit, inductor is dominating, so this phi value is on positive side, 37 degree. Now, to calculate the value of current, you have to invoke Ohm's law. If you remember, Ohm's law says that this is simply voltage upon resistance. Here, resistance has been named impedance. The voltage supply here is 250 volt. You understand? 250 volt is of course the RMS value, so naturally the current which we are calculating here is automatically coming out to be an RMS value of current. So in case you are adding these values 50 ohm to this particular calculation, then it comes out to be 5 ampere. You understand? This is the RMS value of current you have obtained in the circuit, and since the impedance is having a positive implication of angle, phase angle is positive, so overall the current will be lagging and by the same angle, that is 37 degree. Current I is lagging the EMF by 37 degree. This is the complete answer to the question you are having. You understand? Now, if you feel like talking about the voltages which are existing here, just you can say as an additional discussion, let me tell you, sometimes in case the voltage here in inductor, resistor and capacitor are given, then also sometimes it is demanded what is the total supply voltage you have. So let us have the demonstrating part of that kind of question as well in the series circuit. Let us suppose as another exercise, we are giving that the potential drop which is existing across this resistor is 120 volt. That means आपने इसमें कोई एक हॉट वायर इंस्ट्रूमेंट लगाया होगा, यूज किया होगा और उससे इसकी वैल्यू 120 वोल्ट आ रही है. The same hot wire instrument, let us suppose, that is getting applied to this inductor, and say the value which is coming out to be here is 80 volt. And let us suppose if the same hot wire instrument is connected to this capacitor, then the potential drop across capacitor is coming out to be 30 volt. ये सारी situation आपको दी गई. If you have a series RLC circuit and it is connected to some EMF source, then you are getting the voltage values as 120 volt, 80 volt and 30 volt. You have to find out what is the supply voltage here. For the sake of simplicity, I am writing as Vs, so that S is standing for the subscript, S is standing for supply. Now you remember that in series circuit the current is same, and since resistors are being treated as vectors, and whatever orientation these resistors have or reactances have, same kind of phase relationship these voltages also have. What I mean to say is that the potential drop across resistor is always plotted to this side because resistance is being plotted this side. Since the reactance of inductor is being plotted on the upper side, so the potential drop across inductor will also be plotted on this side. And since the reactance of capacitor is plotted on the lower side, so the voltage across capacitor will also be plotted on this side. And that gives you a suggestion that the overall voltage you will be having, that will be a Pythagoras. You can say that the net effect will be VR this side, VL minus VC this side, and the net supply voltage Vs will be simply the Pythagoras of these two values, and this will be VR square plus VL minus VC whole square under root. You understand? So for series circuit involving voltage values, you should use the direct formula Vs is equal to VR square plus VL minus VC whole square under root. You understand? This is the standard formula you should use. Now if you substitute the values for VR, that is given to you 120, and the VL value has been given to be 80, the voltage across capacitance that has been given to be equal to 30 square, and that makes it total complete answer as 130 volt. This is the supply voltage you have. It is not as such that like direct current source you are simply adding them up. That will not suffice the purpose because here they are treated as vector quantities. You understand? So these are the kinds of questions we will be asking for series RLC circuit. Now there is a very important phenomenon involved with the concept of series circuit, that is called resonance. So let us discuss that. Now let us talk about an important phenomenon that is called series resonance. Once again, consider you have a resistor, inductor and a capacitor connected in series. Resistor, inductor and capacitor connected in series to an EMF source. EMF is denoted as E naught sin omega t. If you consider the impedance triangle of that, you have already seen that the resistance was plotted to this side. The reactance value, say again I am considering that inductor is dominant over this, then X value was omega L minus 1 by omega C. And the value of impedance you were having, Z, that was the Pythagoras of this resistance and reactance. So once you were extending this concept of Z, then in the extended form it will be written as R square plus omega L minus 1 by omega C whole square under root. And now I am interested in plotting this Z as a function of omega. So if you consider the situation that on horizontal axis I have plotted omega and on vertical axis I am plotting Z, then you can clearly see that the variation of Z will be something like this. At some particular frequency, you will be finding that the value of impedance has become minimum. This particular frequency you can obtain by making this bracket 0. If you take this term to be 0, omega L minus 1 by omega C as 0, then that will give you the value of frequency. It's a very obvious mathematical property that in case you are adding two quantities which are square and summed, the minimum value can be 0. It cannot go into negative. Now here R cannot be 0. Any other term which you want to minimize, at the most what you can do, you can make it equal to 0. And because of that, जो यहाँ frequency की value हमने obtain की है वो 1 by under root LC है. This is also called resonance frequency. And इस particular frequency पे Z की value minimum होगी. As the frequency will be going above that or coming below that, the value of impedance will be increasing. And on the similar line, in case you are interested in plotting the value of current, अगर आप current की value plot करें, तो current की expression simply EMF upon R square plus omega L minus 1 by omega C whole square है. You understand? The value of current is simply EMF upon Z. ये RMS current की value हो सकती है. Since this value of Z has gone into denominator, then in case you are trying to plot this current as a function of omega, then you will find that current will have a reverse nature, reverse of this. That means on the same particular frequency, you will find that the current is having the maximum value. And this is what we mean by resonance. Resonance का मतलब है कि एक वैसी frequency जहां पे आप देखते हैं कि सर्किट में करंट जो है वो मैक्सिमम हो गया. The resonance frequency is basically that frequency at which the value of current which flows into the circuit, that becomes maximum. And that frequency you are obtaining by simply making this term as 0. Now you have to discuss the various properties of this resonance condition. In this resonance condition, there are several inputs. Sometimes in the question you will find that just by looking at those inputs, you are in a position to decide that the condition is that of resonance. And let us one by one write it down, that what are those things which makes a particular circuit to be resonance circuit of series RLC. Once you have understood that there is a particular value of EMF which drives the circuit in resonance and the current flowing is maximum, First thing you should remember that resonance frequency F will be written as 1 by 2 pi under root LC, and this will be in hertz. In case आपने यहां पे 2 pi नहीं लिखा होता तो ये फ्रीक्वेंसी रेडियन पर सेकेंड में होती, बट इन केस यू हैव इंक्लूडेड F also, then the unit will be changed to hertz. Total impedance of the circuit at resonance वो R के इक्वल हो जाएगी, क्योंकि आपने देखा था जो वैल्यू ऑफ Z आपने देखा था, वैल्यू ऑफ Z, देन इन दिस केस अगर आपने ओमेगा एल और 1 बाई ओमेगा सी को इक्वल कर दिया है तो नेचुरली वहां पे रिएक्टेंस जीरो हो गई है, एंड टोटल इंपीडेंस अगर आप देखें तो ये X जीरो हो जाने की वजह से सिंपली रेजिस्टेंस के इक्वल हो गई है. अगर आप चाहें तो इसको फाई से इंडिकेट कर सकते हैं. द करंट इज मैक्सिमम and I simply will be equal to E upon R, क्योंकि जब पूरी सर्किट की रेजिस्टेंस ही R के इक्वल हो गई है, देन द करंट विच विल बी फ्लोइंग टू द सर्किट विल बी E by R. अगर आपको क्वेश्चन में पीक वैल्यू ऑफ करंट निकालनी है, देन यू कैन राइट इट एज I नॉट, हियर यू विल हैव टू टेक E नॉट. अगर आपको RMS वैल्यू निकालनी है तो यू हैव टू टेक RMS वैल्यू. नाउ also remember that current is in phase with the EMF. You understand? Current is in phase with the EMF. यहाँ पे phase value आप देख सकते हैं, अगर ये जीरो हो गया तो phi बिल्कुल जीरो हो जाएगा, and in that case EMF और current दोनों ही जो है same phase में हो जाएंगे. Now another interesting part you can see here is that once the omega L and 1 by omega C they have been made equal, that means the potential drop across inductor and potential drop across capacitor, that happens to be same when you are having a condition of resonance. Let us write that the potential drop, which I am calling VL, this is equal to potential drop across capacitor at resonance. And in case you have already used that the supply voltage, this is the expression VR square plus VL minus VC whole square under root. And in case you are making VL VC as equal, then naturally the entire expression becomes zero and supply voltage comes out to be that due to potential drop across resistor. That means whenever you have a condition of resonance, then you will find that the total supply voltage, that is simply equal to the potential drop across resistor. दैट मीन्स अगर किसी भी रेजोनेंस सर्किट का आप सिचुएशन देखें तो इमेजिन दैट यू हैव बीन गिवन अ सिचुएशन लाइक दिस इन विच 230 वोल्ट इज मेंशन्ड हियर, 50 वोल्ट इज मेंशन्ड हियर एंड 50 वोल्ट इज मेंशन्ड हियर. अगर ये दोनों वैल्यूज इक्वल दे दी गई हैं, दैट मीन्स इट इज एन इंडिकेशन टू यू दैट यू आर टॉकिंग अबाउट रेजोनेंस कंडीशन. अगर आपको इसमें एक सप्लाई वोल्टेज पूछते हैं, देन यू कैन ऑलवेज से दैट द सप्लाई वोल्टेज इज इक्वल टू 230 वोल्ट. यू कैन ऑलवेज से दैट. दिस इज द मीनिंग ऑफ सेइंग दैट VL इज इक्वल टू VC, दैट इज शोन हियर, एंड VS इज इक्वल टू R. जो भी सप्लाई होगा वही टोटल पोटेंशियल ड्रॉप अक्रॉस रेजिस्टेंस होगा. अगर ये कंडीशन रेजोनेंस नहीं होती, अगर ये एक सिंपल सीरीज सर्किट होगा, देन ऑल्सो the potential drop across these two elements L and C, they will be out of phase by 180 degree. अगर एक प्लस 100 है तो दूसरा एक माइनस 60 हो सकता है, और दी अदर वे अराउंड. अंडरस्टैंड? बट अगर ये रेजोनेंस होगा तो आप कह सकते हैं कि द पोटेंशियल ड्रॉप अक्रॉस इंडक्टर एंड कैपेसिटर they are equal and opposite, their net sum cancels, and you happen to have the total supply voltage same as the total potential drop across resistor. Now connected to this, you can have a concept which you call quality factor, and let us discuss that. Connected to the series resonance circuit, you have a concept called quality factor. There are two ways in which we will be defining it. The one way of defining quality factor Q is that potential drop across inductor or capacitor, because that you know they are same at resonance, upon supply voltage at resonance. ये दोनों ही वैल्यूज जो आप लिख रहे हैं, they should be at resonance. You understand? This is the standard way in which we define the quality factor of a series resonance circuit. Now, as you know that this VL or VC, they are same, so let me take just VL. You can very well take VC, but believe me, you will be getting the same expression. And since supply voltage at resonance is equal to potential drop across R, so you can write it like VR. So this is the expression of quality factor at resonance. Now if you extend the terms you have used here, you know that the current at resonance, that is same whether it is inductor or resistor, so it can be written as I into XL upon I into R. Understand? This is simply as per Ohm's law. Now I and I, they will be cancelled. This is simply XL by R you are getting. XL is omega naught L. I am using this subscript naught to mention that this is a kind of resonance situation you are talking about, and resistance is R. If you further write down omega naught as 1 by under root LC, then this is made as 1 by R under root L by C. So this is the expression of quality factor you are having so long as a series resonance circuit is concerned. If you are interested in increasing the quality of the circuit, then you will have to keep the resistance very low, capacitance low, but the value of inductance must be very high. This is the one of the ways in which you can define the quality factor. But another very useful and interesting manner in which you define the quality factor is something like this. The concept of quality factor becomes very much clear when you again try to see the variation of current with applied frequency. You had seen that the variation of current is something like this. At a particular resonance frequency, the value of current is maximum. Remember that series resonance circuit kind of thing, they are also called acceptor circuit. अगर आप series resonance circuit को देखें, then you see we call it as acceptor circuit as well. अगर आप इसकी application देखें, there are several applications. Very famous application can be tuning of radio. Now the meaning becomes very clear why you are calling it acceptor circuit. For example, this is the circuit of your radio where you have resistance, inductance and capacitance connected together, and from outside the EM waves of any particular radio station is coming in. Any particular radio station will have a fixed frequency omega. So you happen to tune your radio, that means you happen to change the value of capacitance, so that 1 by under root LC of the circuit matches with the frequency of the radio station you have. And for that particular frequency, a very large amount of current flows into the circuit, or you can say a very large amount of current is accepting a particular frequency which is coming from outside, and that is why it is called acceptor circuit. Now the major problem with radio stations were earlier, when the circuit quality was not good, was that on a particular station you were hearing the sound of adjacent radio stations as well. अगर पुराने टाइम के अगर हम सर्किट की प्रॉब्लम्स देखें तो उनकी क्वालिटी अच्छी नहीं थी। उसका कहने का टेक्निकल मीनिंग ये होता कि द फॉल ऑफ द करंट वाज नॉट सडन। अगर आप देखें एक रेडियो स्टेशन की फ्रीक्वेंसी यहां है, अगर दूसरे रेडियो स्टेशन की फ्रीक्वेंसी बहुत ही क्लोज है इसके, तो यू कैन सी कि उस रेडियो स्टेशन के लिए भी इसमें कुछ करंट फ्लो कर रहा होगा। सर्किट में दो रेडियो स्टेशन के करंट आ जाते थे। इन केस द फॉल इज सडन, देन जैसे ही आप ट्यूनिंग चेंज करके दूसरे की फ्रीक्वेंसी पे जाएंगे तो पहले वाले स्टेशन की करंट दूसरे स्टेशन में ओवरलैप नहीं करेंगी, एंड दैट वाज द रिक्वायरमेंट ऑफ गुड क्वालिटी। दैट मीन्स यू कैन से दिस सर्किट क्वालिटी विल बी वेरी गुड इन केस द फॉल ऑफ द करंट विद फ्रीक्वेंसी इज वेरी शार्प। बहुत ही सडन अगर फॉल है तो हम कहते हैं कि सर्किट की क्वालिटी अच्छी है। एंड बेस्ड ऑन दैट व्हाट वी हैड डन, इमेजिन दैट द मैक्सिमम वैल्यू ऑफ दिस करंट इज आई नॉट। तो हमने जस्ट एज अ रेफरेंस एक करंट की वैल्यू आई नॉट बाय रूट 2 चूज कर रखी थी, एंड आई नॉट बाय रूट 2 मीन्स अप्रोक्सीमेटली 70% ऑफ द मैक्सिमम करंट की लोकेशन हम फाइंड करते थे। दैट मीन्स व्हाट आर दोज टू फ्रीक्वेंसीज, वन विल बी ओमेगा 1, another one will be omega 2. These are the two frequencies at which the value of current flowing into the circuit is just 70% of the maximum circuit, and based on that we had defined the quality factor as omega naught upon omega 2 minus omega 1. This was the standard definition we were having for quality factor of the circuit. With this formula it becomes more obvious that if you want the higher quality, that means the denominator is very low, the bandwidth of frequency that is very small, and within a very small frequency change the drop will be achieved to 70%, and of course if you are increasing the frequency more, the drop will be more, and next station overlapping will be completely eliminated. You understand? Here this omega 2 minus omega 1 can be called bandwidth. If you feel like expressing, then you can write it as omega naught upon 2 pi f2 minus f1. And if you try to compare this expression, this quality factor expression as omega naught upon 2 pi f2 minus f1, in case we compare it with the earlier expression we had obtained as omega naught L by R, then you can say the frequency bandwidth f2 minus f1 can simply be written as, here you see f2 minus f1 can simply be written as R upon 2 pi L, and this becomes the essential property of the series resonance circuit which has been applied in any particular tuning radio or any device like that. If let us suppose you have a TV and remote, there also in TV panel you have acceptor circuit, the remote is sending a particular frequency and that is getting accepted by the TV panel. So sometimes in case we demand what is the bandwidth f2 minus f1 which we have written, that is called bandwidth frequency, then it can be expressed in terms of the resistor and inductor connected in the circuit. So that is all we have in our discussion today. Before I move ahead, let me summarize what all we discussed in our today's lecture. In our today's discussion of series circuit and resonance, first we talked about series LR circuit connected to an alternating current source, and based on which we had the example. Then we had series RC circuit, based on which we had another demonstrating example. Then we had series RLC circuit, in which we saw that how current can be calculated, how supply voltage can be calculated. We also saw that voltage across inductor and capacitor, they are always out of phase by 180 degree. And here we discussed a very important concept called resonance, in which we had several implications involved. The resonance frequency was a kind of frequency at which the current which was flowing into the circuit was maximum. That was called acceptor circuit, and several demonstrating facts are involved. In fact, in this particular lecture, this resonance part was the most important concept, and maximum questions are also based on that. Along which you discuss another phenomenon which you called quality factor, and how it helps in tuning your radio without overlapping the currents of neighboring branches, and several solved examples. Concluded the entire discussion of series circuit and resonance. So this is all in our today's discussion, and in the next and concluding lecture we will be talking about the power consumption in circuit and how LC oscillations are involved with the several concepts. Thank you.